Hello, this is Mr. Best. Welcome to Chapter 4. We're going to go through the homework problems 4.8 to 4-13 in this video. Let's go ahead and get started and look on question 4-8. Smallville High School principal is concerned about his school's advanced placement test scores. He wonders if there is a relationship between the student's performance in class and their AP test scores. So he randomly selects a sample of 10 students who took AP examinations and compares their final exam scores to their AP test scores. So you can see the AP scores in the X row and the final percents in the Y row. We're going to create a scatter plot on graph paper. Draw a line of best fit that represents the data. Refer to the math notes box in this lesson. Use the equation of your line of best fit to predict the final exam score of another Smallville High School student who scored a 3 on their AP test. So make sure you go back and look at the math note box in lesson 4.1.1. It talks about scatter plots and line of best fit. So what we're going to do is we're going to plot the AP score on our x-axis and the final percent on our y-axis. So I've labeled my x-axis and my y-axis. Increased my x-axis by 1s, and my y-axis I started at 50 and went up by 10s, each box representing 5 units. Went ahead and plotted the points, and this is what we're looking at. So now I want to draw a line of best fit that represents the data. We try to draw a line that, as I said, represents the data the best it can, so that we can make predictions. I have now drawn in my line of best fit that I feel like best represents the data. Now we're going to use that line of fit to draw or to write an equation of a line. We need to find 2 points. If the line goes through a point, that's fine, we can use it. Otherwise, we'll just try to pick nice points on the graph. So let's see if we can find a couple here. So the 2 points that I've chose, it looks like at 4 it intersects nicely at 85. And then the other one I tried to pick was 1. It looks like it's a little bit above the 65, so I'll go with 66. So those are the 2 points I'm going to use. We're going to find the slope of these 2 points and then find the y-intercept. So I did the change of y over the change of x. I got 19 over 3. I'm going to use that slope in this point, 1, 66. Remember, we're going to plug in y equals mx plus b, y being 66. Your slope is 19 thirds times 1 plus b. So it looks like we'll get 66 equals 19 thirds plus b. Go ahead and subtract 19 thirds from 66, and we will get a value of 59, because that's hard to read, but 19 thirds right there. There we go. And if we subtract 19 thirds from 66, that's 6 1/3, so what would that be? 59 2/3 is what your b value would be, which looks pretty close to where it was crossing the y-axis on my graph. So we have an equation. We have y is equal to the slope of 19 thirds times x plus the b value of 59 2/3. So here's our equation. That might look different than what the book did, because based on my line of best fit it could be different, and it actually is different than what the book has, but it's close to what the book has. Now we're going to make a prediction on if someone scored a 3. Let me read this again, sorry. Use the equation of the line of best fit to predict the final exam score of another high school student who scored a 3 on their AP. So we're going to predict their final exam score. 3 is your AP score, so that's your x value. So 19 thirds times 3 plus 59 2/3. So what do we get? Y is equal to 19 plus 59 2/3. And that's because the 3's cancel right here. So that 3, and that's, remember, divided by 1. And then 19 plus 59 2/3. So if we add, let's see, that'd be 69, 79, so 78 2/3. So their final exam score would be approximately almost 79%. So about 79% if they score a 3 on their AP. All right, next question, 4-9. Solve for x. Check your solutions if possible. So we'll take question A. We'll go ahead and distribute the -2 to both terms, so that'd be -8 plus 6x minus 6x equals 10. combine your like terms. So the 6x, the positive 6x minus 6x will be 0. That cancels each other out, and you're left with negative 8 is equal to 10. So since there's no x value left, and this is not a true statement, there is no solution that will work. And therefore we can't check it because it doesn't exist, or there is no solution to a check. Part B, we have x minus 5 divided by negative 2 is equal to x minus 1 divided by negative 3. A couple ways you could solve this one in terms of what your maybe previous knowledge is of dealing with proportions and ratios. But I'm just going to assume that maybe you haven't done that quite yet and you're not sure. So we're going to take this entire equation on both sides and multiply by the common denominator, which would be 6, to get rid of the fractions. And actually, just go ahead and make it a negative 6 so it cancels the negatives as well. So we're going to take negative 6 over 1 times x minus 5 divided by negative 2 is equal to x minus 1 over negative 3 times negative 6. So both sides are getting multiplied by negative 6. So right here is where I was talking about it canceling. Negative 2 and negative 6. This simplifies to a positive 3 because negative 6 divided by negative 2. And negative 6 divided by negative 3 would be a positive 2. So now we can take 3 times x minus 5 is equal to 2 times x minus 1. And use the distributive property on both sides. Get your variable on one side. In this case, I'm going to subtract 2x, so that's x minus 15 is equal to negative 1. And then I will add 15 to both sides, so x is equal to a positive 14. Now I want to check my answer to make sure that what I did was correct, so I'm going to take 14 and plug it back in to the original. 14 minus 5 divided by negative 2 should be equivalent to 14 minus 1 divided by negative 3. So 14 minus 5 is 9. So we have 9 divided by negative 2. And 14 minus 1 is 3. 3 divided by negative 3. So obviously my answer is not correct because these two things are not equivalent. So I need to go back and check to see what mistake I made. So if we multiply by negative 6, that's 3 times x minus 5, so that looks good. Multiplies by negative 6, 2, that's a 2. Oh, there's my mistake. 2 times negative 1 is not negative 1. Let's fix that. You would think I did that on purpose, right? So this will be minus 2 minus 2, and now 15 minus 2 is x equals 13. So now let's check our new answer and see if we have the right answer. So we get 13 minus 5 divided by negative 2 should be equivalent to 13 minus 1 divided by negative 3. So 13 minus 5 now is 8 divided by negative 2, and 13 minus 1 is 12 divided by negative 3. So is negative 4 equivalent to negative 4? And yes, it is. So there's a perfect example of why you might need to check your work to make sure that it is correct. X equals 13. Next question, 4-10. On the same set of axes, use slope and y-intercept to graph each line in the system shown below, then find the points of intersection if one or more exists. So we're just going to go ahead and graph both of these on the same coordinate plane. I'll graph this one in blue. So we have a slope of negative 1 and a y-intercept at 0, 2. So plot the y-intercept and then a slope of negative 1. Remember, you should be going down 1 and to the right 1, or up 1 and to the left 1, so that your slope or your line is decreasing. Alright, so there's the first equation, and then the second one we'll do in red. And this has a slope of 3 and a y-intercept of 6. So plot the y-intercept, and then the slope of 3 is up 3 to the right 1, or down 3 and to the left 1. So we can get a couple points, and then we'll graph it. And so there's the second equation, and it says then find the point or points of intersection. So we're looking for where they intersect, and it looks like it intersects right here at this point. So the point of intersection will be, looks like -1, 3. That's the ordered pair, and it only intersects in that one spot. For 11, a team of students is trying to answer the scientific notation problem. Jorge thinks they should use a generic rectangle because there are 2 terms multiplied by 2 terms. Cadell thinks the answer is 8 times 10 to the 10th, but he cannot explain why. And Lauren thinks they should multiply the like parts. Her answer is 8 times 10 to the 21st. Who is correct? Explain why each student is correct or incorrect. So for each of these, it is multiplication. Jorge is incorrect because with the generic rectangle, we're looking for 2 terms. There is not 2 terms. These are both being multiplied. They're not being added. So you would need addition to have the 2 separate terms. So Jorge is not correct. Lauren thinks you should multiply the like parts. Her answer would be 10 to the 20, well, actually 10 times 100 times raised to the 21st. But the properties of exponents, we would add the exponents. So Cadell is actually right, and the reason why is if you have 2, I don't really like to use an x here, but 2 times 10 to the 3rd power times 4 times 10 to the 7th power, everything's multiplication, so we can move things around. So this is 2 times 4 times 10 to the 3rd times 10 to the 7th. So 2 times 4 is 8 times 10 raised to the, and how many 10s do we have? This is 3 10s and 7 10s, so that gives you a total of 10 10s. So Cadell is actually the one that is correct on this one. 4-12, we're getting back to generic rectangles. We're looking for the dimensions, the length and the width, and then write the area as the product of the dimensions and as a sum. So on this one we have on part A, so what's in common here? We have a length of 3 and then also a y value. And so 3y times y gives you 3y squared. And then -12 divided by 3 would be -4. So -4 times 3y is -12y. So on part A, if you take the length or width 3y times y minus 4, then you'll get the sum of its parts, which is 3y squared minus 12y. For B, if you take a look, kind of the same thing. Actually, the top part is the same. So this would be 3y, and then that means that's y and -4, so that kind of helps out. And then on the bottom, you have here, -4 times what gives you -20. That would be a +5, and 5 times y also gives you 5y. So looks like we have a length and width of 3y plus 5 times y minus 4. So those are the length and width, or the other way, doesn't matter, is equal to the sum of its parts. So you have a 3y squared. 5y and -12y can be combined to give you -7y, and then -20. So that's the this is your product, which is the length and the width, and then this is the sum of the parts. All right, and the last one for this homework is 4-13. A prime number is defined as a number with exactly 2 integer factors, itself and 1. Jeannie thinks that all prime numbers are odd. Is she correct? If so, state how you know. If not, provide a counterexample. So are all prime numbers odd? Well, I guess then the question is, can we think of an even number that only has 2 factors? And once you get into your even numbers, we know 2 is a factor of all even numbers. So once you get to 4, you have 2, and then you also have 1 in itself. But if you look at number 2 itself, it has only 2 factors, 1 and 2. So we did provide a counterexample, and for this one, the answer is no, not every prime number is odd. There is one that is even, and it is the number 2. So 2 is a prime number, and it is also even. And that's a counter example. All right, that is it for homework problems 4-8 to 4-13. See you next time.